Hi, in this video I will cover the usage of CM600 and CM700D. To begin, I will show you what's included in the packaging. Okay, with the purchase of CM600D, it will include a set of two target masks, which is the MAV target mask for medium aperture. Okay, whilst the CM700D provides an additional two target masks for SAV or the small area measurement. Okay. Both these models include a wide calibration plate, a USB cable, and also an AC adapter, which I already have it connected. Okay. So the difference between the CM600 and CM700D will be only on the target mask. Okay. So on the equipment, okay, both the models include a display with a set of buttons. You have a button for sample measurement, target measurement, calibration, menu, as well as a up, down, left, right arrow key and a center button to select. Okay. Over on this side, we have a port for AC adapter connection, port for USB, a measure button over here, and a selector switch for MAV and SAV. This selector switch is only available on the CM700D model. On the CM600D model, this selector switch would not be there. Okay. Over on this side, we have a switch to power on the equipment. Okay. And on the other side, there is a compartment to place. Oops. It's a bit tight. Yeah. There is a compartment to place the batteries. Okay. Included with the equipment will be 4 AA batteries. You could use a standard alkaline battery or a rechargeable battery. Okay. And over at the bottom is where we could place the target mask. For this video, I will be using the MAV target mask. Okay. So to begin the operation of this equipment, I will place the AC adapter. I could also run it on battery. Okay, and I will turn on the switch too, and I will switch on the equipment. Okay. So over here you can see that once the equipment gets switched on, it will prompt for calibration. So there's two types of calibration. One would be the zero calibration, okay, and the other is the white calibration. I will cover both the calibration procedures. So since the white calibration was highlighted, I would select zero calibration to perform the zero calibration. Okay. In order to perform the zero calibration, the procedure would be to aim this equipment into an open space whereby there's no obstruction at least 1 meter ahead. So best would be in an open space when there's nothing around the equipment, and just press the measure button over here. Okay. You will notice that the night light is flashing, and on the display it would show you the number of measurements it's taking. It requires 5 measurements for zero calibration. Okay. Once it has done, it will prompt for white calibration. In order to perform the white calibration, simply take the white calibration plate and just clip it on. Okay. It's a clip-on mechanism, and over on the display it shows you white calibration, and you can just press the measure button. So it shows you the number of calibration measurements is taken. It needs to take 5 measurements for white calibration also. Okay. Once it is done, it will prompt you the normal display of LAB. Since I do not have any previous sample measurement, it shows with dashes, but if you have taken some measurements, it will show you the previous measurement results. Okay. So now that we have performed the white calibration, we can remove the white calibration plate. If you notice, there's a clip over here, so you need to engage this clip and pull out the white calibration plate. Please do not directly pull out the white calibration plate, as it may damage the target mask, or it may damage the target this portion of the equipment. So please engage these two clips and remove the white calibration plate, and if possible please cover the white calibration plate. Okay. So moving on, after the calibration we could immediately take a measurement of a sample. So for an example, I have a color card and I can directly take measurement by placing the equipment flush on the sample. That means this part will be direct contact onto the sample, and we press the measure button over here. Okay, over here we press the measure button. Okay, so once the sample has, I made a mistake. Okay. So once the sample has been measured, there will be a set of readings which will be the LAB readings. These LAB readings refer to the color of the object. Just to give a brief introduction, okay, I will explain the LAB color readings. So the LAB color scale, okay, sorry for some reflection. Okay, so the LAB color scale uses three parameters, which is the L, A and B. The L is a lightness scale ranging from white to black, okay, whereas the A and B would be denoting red, green, yellow and blue. Okay, so I will cover on the L first. The L value is a scale from white to black, whereas L100 is white color and L0 is black. So any shade in between will provide different values. Okay, as for the A and B, it's typically used a cross section of this diagram. So the A and B values are typically used this diagram to okay. So what is required to know is if the A value is positive, the color will be in the direction of red. If the A is negative, the color will be in the direction of green. If the B value was positive, the color would be in yellow, and the B value negative will be in blue. So when we perform a measurement, we will get a series of L value, for example L50, and A will be in positive, so maybe A positive 20 and B positive 30, for example. So the direction of A and B will actually tell you which direction the color is, and the number would denote the intensity of the color. Keeping this in mind, let's take a measurement of this red sample again. So I place it on the sample and I click the measure button. So this gives me a set of reading. Okay, L value of 39.52, the A value of 40.56, and the B value of 21.66. So let me explain one by one. Okay, so the L value is the denotes the brightness of the sample. So since this sample is slightly a dark red, hence the L value is 39. Okay, so the lower the L value, the darker the sample is. Okay, so A value, as I mentioned, A positive will be a red color, so this color is positive 40.56, so denotes that the A is positive, so it's red color, and the B positive denotes yellow content. So B value of 21 says that this color has red and also yellow content, as well as based on the L value, it's dark color. Okay, let me measure another sample on blue. Okay, once again I will take the equipment, place it on the color and press the measure button. Okay. So since this is also a dark blue color, we have the L value at 38.24. Okay, the A value in this sample is negative 5.65, which denotes that this color is slightly greenish, and the B value is negative 30.78, so which shows that this color is indeed in blue. Okay. So this is a rough explanation of LAB. Okay. This color chart will be available to download with the link provided. Okay. So carrying on, let me explain the color measurement function. So there's two buttons here. One is for sample color and one for target color. So target color, it can also be known as a color standard or master color, whereby this equipment is able to do color difference measurement. Okay. So in order to do color difference measurement, one would simply have a reference color and also have a sample color. So in this example, I will take this as a reference color and I will take this as a sample color. So how do we establish color difference measurement? Is by first clicking on the target. Okay. Dash 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 means there is no value assigned to this target, and you can see that this target is target 001. So I will take my equipment, place it on the master color or reference color and click the measure button. Okay. So it has provided me the color values or LAB color for the reference color or target color. So now when I want to measure the sample color, I have to click on the word sample. If I do not click on sample and measure, it will prompt me whether I would like to override this target. So I click on sample. Okay, and now I can proceed to measure on the sample color. So now it provides me the LAB of the sample color. So you can see, if I click back on target, this was the color values for the reference color, and this is the color value of the sample color. So if you, in order to see the color difference, you may have to switch the display by pressing left or right. Okay. So yeah, so this display, which shows delta L, delta A and delta B, and also delta EAB, will refer to the color difference. So delta L is the changes of the changes in the L value, delta A is the changes in the A value, and delta B is the changes in the B value, whereas delta E is a custom form. Delta E is a color difference formula which denotes the total color change. Okay? So the higher the number it is from 0, means the more color change there is. So in order to get the if the color of the reference and the color of the sample was same or almost similar, these values will be closer to 0, including the delta E will be closer to 0. So the higher the values is, the more color difference there is from your reference and sample. For more information on this color theory, we actually do have a webinar on this, so you could access the webinar content with the link provided later on. Okay. So to recap, so target measurement was to measure the reference color, and sample measurement is to measure the sample color. So what if we would like to register another target? So we will go back to the target mode. Okay. If this target 1 already has a set of data, measuring over this, so for example, I will measure on the red. The equipment will prompt whether we would like to override this target. So in order to create a new target, we would have to press the down arrow key, and this will channel to target 002. Okay. Now we could measure this. Okay. And this will provide the data for target 002. So we can scroll up and see that this was target 001 and this is target 002. Okay. So similarly, now we are in target 2, we could click on sample and measure the color difference of the next sample. Okay. So this will show the color difference between the sample and the target color. Okay. So in order to, for an example, if you were running two different samples and now we are running on red color and now we are going to go back to the blue color. So all we have to do is click the target, scroll back to target 1, okay, get target 1 selected and click sample again. So this has selected back target 1 and we can take measurements on blue samples again. Okay, so this will actually tell you the difference between the blue target and the sample. Okay. So an additional feature is that in the target mode, if we were to click the center select button or save select button, in the target mode, if we were to click the menu button, okay, we have a list of entries, and one of the entries could be edit name. Here we could actually edit the name of the target. It could be a product code, it could be a general classification of blue. So you can edit the name by moving the cursor left and right and up and down to change the characters. So when you're done, you can click the center button to save. And since the default name was no name, now you can see that target 1 has a name of no name. Okay, and if we click the center button again, it will show you the list of all the targets. So it shows that target 1 has no name and target 2 has no name, and those that doesn't have anything beside it means that these targets are empty. So in future, if you would like to channel through multiple targets, you can go to the target mode, select the list and scroll through to select a certain target. Okay. I'll go back to target 1. Okay. So I would explain the other buttons. Okay. So this button would be to access the calibration menu at any point of time. So if you choose that every 4 hours you would like to perform a calibration, so instead of switching on and off the equipment, you could just directly hit the calibration screen. And if you would like to perform the white calibration again, oops, I clicked it by mistake. Okay. So if you like to perform the white calibration again, you can place the white calibration plate inside and perform the white calibration. Okay. And going back, so the menu button would give you a set of options. You would have print, delete, edit name. There's also list, auto target and delete all. So if you'd like to delete a sample or target, you can go delete. It will prompt, oh sorry, this is edit name, my apologies. Menu, could go to delete, and if you like to delete a certain sample, you can click OK. So that sample or that targets get deleted. Okay. If you want to delete all the data, you could go to menu, go right to the bottom and click delete all. Okay. So it has completely removed all the data. Okay. So another function to note is that there is 2 sets of measurements. One is the SCI measurement and SCE measurement. It's 2 different modes. So over at the top here, you can see that this measurement is for SCI. SCI. This is for SCI. And if we scroll the display left or right, we will get SCE measurement also. So it's SCE is always in gray and SCI is in yellow. So you have a set of LAB for SCI measurement and you have a set of LAB for SCE measurement also. Same goes to color difference. You have the, oh, this is not in color difference mode, sorry. So even for color difference, you have delta LAB in SCI mode, and you have delta LAB in SCE mode. So it's very important to note that for your color management, are you using SCI mode or you're using SCE mode? So it's not, you cannot compare the results with SCI against SCE. Okay, so I'll explain why is there two different modes. So SCI mode stands for specular component included. In an easy term to understand SCI mode does not take into account of color change due to appearance. Okay, let me illustrate. So I have a, let me zoom out. Okay. I have a sample plastic piece, okay, from a single mold, black piece, but with different surface conditions. I hope you can see it well here. So on top here it's high gloss, and at the bottom it's matte gloss. Okay, so SCI mode is a mode where it will measure color without the interference of the surface condition. So if you can notice that typically a surface with matte gloss will always look lighter than a high gloss surface. Okay, so for the SCI mode, it's a measurement that does not take into account of surface texture or glossiness, whereas the SCE mode works exactly as how it was to be in visual, meaning that if there was a color change or appearance change due to the glossiness or the appearance, then the SCE mode will detect it. Okay, to illustrate this, okay, I will take a target measurement on the matte gloss, and I will take a sample measurement on the high gloss, and we will view the color difference in SCI mode and also SCE mode. Okay, so in order to do that, I will click target. I will use a new target. Okay, over here. Let me get back the display. Okay. So I will take a target over here on the matte gloss. Okay, so we have a LAB in SCI. Okay, and I'll go to sample, and I will take the sample measurement on the high gloss. So in the SCI mode, okay, if I were to compare a matte gloss and a high gloss, if you look at the color difference in delta E, it's only 0.49. Okay, however, in the SCE mode, due to the actual visual difference, the SCE mode shows the delta E of 12.05. Okay, this would mean that in actuality, the SCE mode will actually measure the color based on visual appearance, while SCI mode can actually indirectly just measure the color pigment. Okay, because in this scenario, both this entire plastic plate was made out of one single pigment or resin in a single extraction, just with different surface conditions. So that would denote the difference between SCI mode and SCE mode. Okay. So next I will explain about changing to different target masks. Currently I am using the MAV target masks. So in order to change to a small area viewing, okay, the reason of changing to a small area viewing is in the event that you are measuring a small part, for example, a part of this diameter or this dimension, if you're measuring it with the MAV, it may induce some kind of gaps. I'm not sure if you can see, so you can't really cover the sample properly. However, with SAV mode or small area viewing, you may be able to measure the parts better. Okay, so in order to change, what you have to do is change the selector switch from MAV to SAV or SAV to MAV accordingly. This one, this target mask is a twist type, so you twist to open it, okay. And when you place it back, you place the SAV on it and twist to close, okay. So every time you change between MAV to SAV, we recommend to do the calibration. So click on calibration, place the white tile for white calibration. The zero calibration would not be necessary, and perform that calibration. Okay. So now we have the equipment set on SAV mode with the SAV target mask. So you can perform the measurements using this setup. So next I would like to show you the menu options. So I've covered the menu settings. There's also options. So if you notice that there's a word options over here, which require you to press both this button, menu and the down button together. So when we press these two buttons together, we do get another set of options, which is display conditions, measure conditions, tolerance, communications, settings, and instrument. Okay, so I cover one by one. The display condition would actually allow you to change certain parameters like the display type, the color space, any indexes, the observer degree, the illuminant. So these are typical settings that require to be set up with color measurement. Typically the default illuminant will be D65 and the observer is set to 10 degree. So and the color space is set to LAB, L star, A star, B star. So if there's a need to change it to another set of units depending on the requirements, this is the place to go to. Okay. The target button acts as a back button. Okay. In the measurement condition, we can actually choose whether we are measuring SEI or SEE simultaneously. Or we can just choose that to measure in SEI only or SEE only. To change the selection, you can press the select button, okay, and it will actually prompt you whether you want SEI only, SEE only, or SEI plus SEE. There is also auto average and also a manual average over here. Auto average and manual average will be useful when you're measuring either curved part or big surfaces. So example for this part, okay, due to the curvature of the part, we would actually recommend to do either manual or auto averaging to measure different sections of the part and get an average reading on it. Okay. The tolerance settings, you can have multiple tolerance settings. So these tolerance settings would actually be to identify the upper and lower limit for the LAB in order to determine whether the sample is pass or fail. I have to go back to the menu. Communication will be some setup with the communicating with the Bluetooth printer or with the PC. This equipment comes with a built-in Bluetooth inside. So if you have a Bluetooth printer or you want to communicate with the PC with the software using Bluetooth interface, this would be the setup. Some general settings for language and for power and date and time, and the instrument page will give you some details of the instrument. So this would cover the basic usage of the CM600 and CM700D. If you'd like to know more on any particular functions or any questions in general, please feel free to contact us. Thank you.